So let us begin with lecture 3 of moving charges and magnetism. So in this lecture we are going to calculate the value of magnetic field due to a current element, or we can say that we will be learning Biot-Savart law and its application. So let us begin by stating Biot-Savart law. So this law is basically stated to calculate the strength of magnetic field from a current carrying element or a current carrying wire. So for our convenience we are considering that there is a current carrying wire which is something like this. We can take any curve. So for the time being we are taking something like this as the current carrying wire. So this wire is carrying a current I in this direction. Now if we select a patch on this segment which is of length dl, so this is of length dl, and we are calculating suppose magnetic field at a distance r from this current carrying element, and this r is making an angle theta with the current element dl, and we are calculating magnetic field at a point p. Now the strength of magnetic field at a point P due to this element, which we are calling it as dB. So the direction of magnetic field at the point P is certainly in the inward direction, which we have already learnt and can calculate from Maxwell's right hand rule. So if we place our thumb in the direction of current carrying wire, then our palm will give us the direction of magnetic field. So in this part, if we discuss about the magnitude of magnetic field dB, so the strength of this magnetic field dB is directly proportional to the current and the length element. So it is proportional to both current and length element, which which we can call in a combined way as current element. So it is depending upon current and this length dl. So it is regarded as the current and the length vector of the current element, and it is inversely proportional to the square of the distance from the current element. So I can say that from here we write it as dB is equal to mu naught IDL sine theta upon 4 pi r square, where the angle theta is measured from the current element. The angle theta is measured from the current element. So this is the strength of magnetic field which we have calculated. So we can express the Biot-Savart law in vector form. So if I write this equation in vector form, so we can state it as that dB vector is equal to mu naught upon 4 pi I dl cross r upon r cube. So we can express it in vector form as in this fashion, that is dB vector is equal to mu naught upon 4 pi I dl cross r upon r cube. Now this value mu naught is called as the magnetic permeability of vacuum, or we can simply call it as permeability of vacuum. So mu naught is a constant and is regarded as permeability of free space or vacuum. Permeability of free space or vacuum, and the value of mu naught is equal to 4 pi into 10 to the power minus 7 Tesla meter ampere to the power minus 1. So the SI unit of mu naught is Tesla meter ampere to the power minus 1. So this is the value of the permeability of free space which we are going to use. It must be very well kept in mind that the angle theta which we are referring to in this particular equation is measured from the current element. So this is the angle theta which we are talking about, and it is measured from the current element. So we are taking a small illustration to understand this concept. So I am taking a small illustration. So we are considering that a wire is placed in the north-south direction and is carrying a current of 10 ampere. So when I say north-south direction, I mean to say something like this. And it is carrying a current of 10 ampere in this direction from south to north. So over here I can mention that this is north and this is south, east and west. So it is carrying current of 10 ampere from south to north. And let us suppose we are calculating the magnetic field at a 1 centimeter piece of wire at a point 200 centimeter northeast from the piece. So over here we are selecting a small 1 centimeter piece of wire, and due to this 1 centimeter piece of wire, suppose we are calculating the value of magnetic field at a point P which is 200 centimeter northeast from the piece. So basically it is making an angle of 45 degree with the current element. So if we write the expression for this particular illustration, so I can write that dB is equal to mu naught upon 4 pi I dl sin theta upon r square. So using the law which we have already stated, so we can put the value of mu naught as 4 pi into 10 to the power minus 7. So we are eventually left with 10 to the power minus 7. The value of current which we are discussing is equal to 10 ampere. So dl is equal to 1 centimeter, which is equal to 10 to the power minus 2 meter. Sine of 45 degree. The angle is measured from the current element upon r square. So it is 2 meter. So we write it as 2 square. So over here we attain a value of this small magnetic field which is equal to 1.8 into 10 to the power minus 9 Tesla. So 1.8 into 10 to the power minus 9 Tesla will be attained. So the direction of B vector is the same as the direction of dl cross r, or we can also calculate it by using Maxwell's right hand rule, which is the more convenient way of calculating it. Now the next point which I wish to mention over here is that the Biot-Savart law for the magnetic field has a certain similarities as well as some differences with the Coulomb's law. So we are stating these points which is going to lay a similarity or point of difference between the Biot-Savart law and the Coulomb's law. So the first point which we state over here is that both are long range. So we are saying both are long range. So when I say that both are long range, so I am basically saying that since they both are depending upon the inverse of the square of the distance from the source, that is, in case of the Biot-Savart law, we are taking dB is inversely proportional to r square, and similarly we are taking for a electric field that electric field E is inversely proportional to r square. So that is the first point of similarity that is between them. So they both are long range, and the value of B is inversely proportional to r square, and so is the value of electric field, which is also inversely proportional to r square. Now the next point of similarity between them is superposition principle is applicable for this both the concepts. So we say that if there is a system which is having ability of producing more number of electric field, so electric field at a point will be given by the vector sum of all the electric field which is generated by the charge or the sources in that region. Similarly, the magnetic field will be due to the all the current segment or the current element present in that region. The next point which we are saying, which is a point of similarity, is both the electric field and the magnetic field are produced by scalar source. So they both are produced by scalar source. So when I say they both are produced by scalar source, one point is clear, that the value of electric field is produced due to a charge which is a scalar quantity, and the value of magnetic field is created due to current. So current is again a form of a scalar quantity. But we can also say that the magnetic field is produced by a vector source, that is ideal. So it is having a vector source in the form of ideal vector, and it is having a scalar source, and the source is current. But the root cause of magnetic field is also current, which is again scalar. But when we express it out, we say that it is written in the vector form, that is ideal vector. So they both are produced by scalar source. Electric field is produced due to charge and magnetic field due to current. But when we write the equation, we write E equal to kq by r square, which is completely scalar, and the value of B is in terms of ideal, which is current element and is a vector quantity. So the next which I say is that the value of electric field from a point charge is written as E equal to kq by r square. So the value of electric field due to a charge will be in the direction of r, maybe away from it or towards it. But in case of magnetic field, when we write dB is equal to mu naught IDL sine theta upon 4 pi r square, so there is nothing as such. So the value of magnetic field is in fact perpendicular to the length r. So if I mean to say something like this, that if this is the current carrying wire I, and we are saying at a distance r, so the value of magnetic field over here will be directed into the plane of paper in the inward direction. So the direction of magnetic field is in fact perpendicular to r. So this is a point of dissimilarity between them, or a point of difference between them. Now the next point which is to be kept in mind over here is this expression. So I am establishing a relation between epsilon naught mu naught and speed of light. So now according to this very famous equation, C is equal to 1 upon root over mu naught epsilon naught. So from here we can say that both of them are convertible. That is, I mean to say that from here I can write that C square is equal to 1 by mu naught epsilon naught. So we can write mu naught as 1 by epsilon naught c square, or we can write epsilon naught as 1 upon mu naught c square. So they both are convertible into each other. So now we are considering to apply the Biot-Savart law for the calculation of magnetic field. So we are calculating magnetic field due to a current in a straight wire. So this is the first derivation which we are doing using Biot-Savart law. Magnetic field due to a current carrying straight wire. So we are considering a wire Mn which is carrying current in this direction. We are considering that Mn is carrying a current like this. So this point is stated as M and this one is stated as N. And we are looking forward to calculate the strength of magnetic field at a point P, which is somewhere here. Let us say at a distance D from this straight current carrying wire. So for the time being, I am saying that P and M and P and N are joined, and we are considering that this angle as theta 1 and this angle which is from the current wire is theta 2. So now in order to calculate the value of magnetic field at a point P, so at a certain distance from this point of intersection, let us say at a distance y, I am selecting the current element and this is the distance r from the current element, and we are going to use this angle theta. So if we apply the Biot-Savart law for this small current element, so we can write it as dB is equal to mu naught IDL sin theta upon 4 pi r square. And from the diagram I can state that if we consider this length segment, so I can draw this triangle over here, and we can say that if this is y and this is d, this one is r, and the angle theta which we have calculated over here is this one. So for the exterior angle theta, I can write that the distance y is equal to minus d cot theta, and hence from here we can write dy as d cosec square theta d theta. And from this expression we can also put, or from this triangle we can also put, r is equal to d cosec theta. So if we substitute these values in this expression, so I can say that the value of dB will be reduced to mu naught I upon 4 pi d sin theta d theta. So this will become the value of magnetic field dB, and we are integrating it from theta 1 to theta 2. So the limit of integration will be from theta 1 to theta 2, and that will give us the total strength of the magnetic field due to this wire. So I can say that the value of magnetic field can be thus calculated as mu naught I upon 4 pi d cos theta 1 minus cos theta 2. So this is the value of magnetic field that we have. Now if I consider that the wire is infinitely large, so if the wire is infinitely large, so we can say that theta 1 is equal to 0 degree and theta 2 is equal to pi, and hence the expression will be reduced to mu naught I upon 2 pi d. So over here it must be kept in mind that for the calculation which we have done, we have measured theta 1 and theta 2 from the current carrying wire. There is also some derivation which is done in some textbook where the angle is calculated from P. So be very cautious while using this formula or applying the formula. So if you are following this, then kindly make sure that you apply the equation by considering the angle from the current carrying wire. So in the next derivation which we will be doing, we are calculating magnetic field due to a circular arc. So we are finding magnetic field due to a circular arc. So we are considering a current carrying circular arc like this, carrying a current I, and I am joining the two ends of this segment to its center, considering that it is making or subtending a total angle of alpha. Now I am drawing a central line for our calculation purpose. So I am basically dividing it into two half, and let us say that if we consider a small patch at an angle theta subtending an angle d theta at the center, something like this. So at an angle theta we are subtending a small d theta at the center, and we are considering that the radius is equal to r. So the length of this segment is going to be equal to r d theta, and it is carrying a current I. So the value of magnetic field at this point P, so from Biot-Savart law I can write that the value of dB is equal to mu naught IDL sin theta upon 4 pi r square. So from this expression one thing is clear, that we can write that the value of dB is equal to mu naught, current is I, the length segment is equal to r d theta. Now if we apply, while applying the Biot-Savart law, as I have already mentioned, the angle is measured from the current carrying wire or from the current element. So this current element is basically tangential to this line. So the angle of sine theta will be 90 degrees. So sine 90 will be written as 1. And then we have this expression as upon 4 pi r square. So from here I can say that the equation is reduced to mu naught I upon 4 pi r integration of d theta. And the value of the limit of integration is from minus alpha by 2 to plus alpha by 2, and hence I can say that the strength of magnetic field B is equal to mu naught I upon 4 pi r and the total angle alpha. So this is the value of magnetic field that we have for the current carrying circular arc. Now we can modify this formula to obtain the current or the magnetic field at the center of a circular current carrying circular loop. So if I modify this formula, so I can say that for a current carrying circular loop, so for a current carrying circular loop, the total alpha angle will become equal to 2 pi, and hence the magnetic field equation will become mu naught I upon 4 pi r and the alpha will be equal to 2 pi. So this expression can be written as mu naught I upon 2r. Now if suppose there are n such current carrying loops, so if there are n such current carrying loops, so I can say, so I am writing if there are n such current carrying loops, so now the magnetic field at the center B net will become equal to mu naught Ni upon 2r. So this is going to be the magnetic field at the center of the current carrying circular coil. So in the next derivation we are moving ahead to the calculation of magnetic field at a point on the axis of the circular current loop. So we are saying magnetic field on the axis of a circular current loop of a circular current loop. So if we consider something like this, so we are stating that we are calculating magnetic field due to a circular loop of radius a at a distance x from the circular loop. So we are basically stating or trying to calculate something like this. So we are considering that this is a current carrying circular loop carrying current I having a radius r, and we are calculating magnetic field at a distance x from the center of this loop at a point P. So if we consider something like this, so one thing is for sure true, that for this current carrying circular loop, the value of magnetic field can be calculated by first of all selecting a current element. So we are selecting a current element and we are drawing a line joining the current element and the point P. So due to this, I say that the value of magnetic field will be somewhere in this direction, which is marked as dB. So if we place our right hand thumb in the direction of current carrying coil, so our palm will be pointing in the direction of dB, which is somewhat like this. And I can say that there will be two components of dB. One will be directed away from the circular current carrying loop and the another one will be pointing towards the left or towards the negative x-axis direction. So if I consider this angle as theta, so this component will be written as dB cos theta, and the another component will become dB sin theta. So now this component which is equivalent to dB sin theta will not contribute for anything, because the another component which will be coming from this current carrying element will nullify the effect of dB sin theta. So the value of magnetic field is directed away on the axis of the current carrying circular loop. So if we apply Biot-Savart law for this point, so I can say that the value of dB, so the value of dB can be written as dB is equal to mu naught IDL upon 4 pi, and the distance is equal to x square plus r square. So we are taking it in this way. Now since the element dl is placed in the another plane, so the displacement vector r, which we are saying as x square plus r square, from the dl to the axial point is in the another plane, and hence the value of sin theta is equal to 90 degree. So now if we calculate the value of magnetic field on the axis of the current carrying circular coil, so the value of magnetic field on the axis of current carrying circular coil is equal to dB cos theta. So from here I can write that the value of cos theta is equal to r upon under root of x square plus r square. So basically if this angle is theta and this one is 90 degree, so this will be 90 minus theta, and hence this angle will be theta which we are carrying for. So from this triangle I can say that cos theta is based by hypotenuse, that is r upon under root of r square plus x square. So if I put the value of dB, so we are left with mu naught I dl cos theta upon 4 pi x square plus r square. So if we integrate this expression, so we will get the value of magnetic field on the axis. So we get something like this. Now in the value of cos theta, everything is constant, so I can take them out. So it will be equal to mu naught I r upon 4 pi x square plus r square to the power 3 by 2, and there is integration of dl that is left. So if we integrate all the dl, so all the length segment on this current carrying circular coil will add together to give us the total length of the coil, which is equal to 2 pi r. So if I put the value of dl as 2 pi r, so the magnetic field on the axis of the current carrying circular coil will become mu naught I r square upon twice of x square plus r square to the power 3 by 2. And if suppose there are n turns, so we multiply this expression with n. So we will obtain an expression like mu naught ni r square upon twice of x square plus r square to the power 3 by 2. So this is the value of magnetic field on the axis of the current carrying circular loop.